Boom! Yes folks, Hume here again. So this video is the one where we're gonna properly wind up the series of videos on Pythagoras theorem and trigonometry. We can do that by solving a hypothetical situation that involves using both Pythagoras theorem and the trigonometric ratios. This is a simple demonstration of some of the kinds of questions you could get in an actual exam, right? And as you go through your exam, past papers and whatnot, you will see questions that look something like this, where they give you a composite shape, right? Triangle mixed with something else, and you had to use a combination of Pythagoras theorem and the trigonometric ratios to solve the question. Of course, there will also be the other types of questions where they give you a paragraph and they describe a situation, sometimes with the aid of a diagram, sometimes without the aid of a diagram, right? A cliff somewhere, or a track somewhere, or the top of a house somewhere, or the length of a boat somewhere, or some kind of real life scenario that you could actually encounter where you'll actually have to use your knowledge of trigonometry and Pythagoras theorem to get the answers. However, I wouldn't be doing any of those in this series of videos. You will get that inside the paid platform, where we will actually be spending time doing past paper questions, right? Not just from CSEC, but from other examining bodies around the world. The idea is that after you go through the knowledge, then you have to practice. Again, it's like learning to play a musical instrument, right? It doesn't matter how much videos you watch or how much classes you attend. It doesn't matter how many books you read. It doesn't matter how many gurus you talk to. At some point, you have to sit down with the instrument and go through whatever you have to go through. Hit your off-key notes. This, that, make a wrong turn here, make a wrong turn there. That is part of the mathematical process. And that is the part that I want to spend the most time on in the platform, right? So in the platform, yes, the same information I get here will also be found in the platform. The difference, however, is that in the paid platform, you will have questions. And you wouldn't just have questions. You'll have solutions to the questions so that you could monitor yourself, and you will also have the opportunity to interact directly with me and with other people who in the platform as well. All right, so that's basically it. Check it out. Let's get the thing done. So let me work out the problem. So we have this diagram, and let us say you get a question like this in an exam. Here what they will tell you. They will say the figure W, the figure PQRSTW is a quadrilateral, right? Quadrilateral meaning, sorry, let me rephrase that. They will say PRSW. So PRSW is a quadrilateral, right? Let me take it up here because I don't want to use this space. PRSW is a quadrilateral. They will say that PQST is a rectangle. Alright? So PQST, they will say that is one piece of information there. Second piece of information, let me come here with that now. Second piece of information here is that PQST is a rectangle. Alright, don't mind, we had to squeeze up, right? We're using the board that we have. There will be other instances where we have bigger boards, but we will talk about that a little later. Yeah. So they give you two pieces of information. One is that PQSW is a quadrilateral, which means it has four sides, and within that quadrilateral you have a rectangle PQST, and they tell you also that angle QRS is 30 degrees, and they tell you also that angle PWT is 45 degrees. So they tell you that angle QRS is equal to 30 degrees. Notice how I write it, QRS. So the angle is always at the letter, the vertex at the letter in the middle. So anytime I describe an angle in a shape, use your three letters, right? Because the three letters will form two sides. The vertex will be at the letter in the middle, and that is where the angle is. Usually they'll have a little arrowhead on top, just to remind you that that is where the angle is. Sometimes they wouldn't have this, but even if they don't have it, you know that that is where the angle is. See how much extra things they get in here? Over here now, they tell you that the angle PWT is equal to 45 degrees. Same story, PWT, the vertex is at W, that's where the angle is, 45 degrees. And here what they ask you to find, they say find the perimeter of the shape PRSW. So in other words, they wanted to find the perimeter of the whole quadrilateral given the area, given the shape that they outline here. Alright, so again, just for the sake of clarity, I will erase some of the extraneous stuff here because I want to use most of the space to actually write out the solution while we're talking about it. So, alright, we go in now. Right, so we have the thing here as clear as day. What's the perimeter? We know that the perimeter is the distance around any shape. Right? And again, I'm taking the extra step of slowing down when I'm talking about these things because these are the simple things that sometimes in the Caribbean context, you're dealing with a Form 4 student or a Form 5 student, and you give them a shape and you tell them what's the perimeter of that shape. They want to know what perimeter mean. Alright? So we're not taking things for granted because we know that even though we expect that generally speaking a student should be at a certain place by a certain time, we know that it doesn't actually work out like that in a lot of cases for a whole host of reasons, a lot of which have nothing to do with mathematics, but as a separate conversation. Yeah? So we know that the perimeter is the distance around the shape. So the perimeter would be this whole distance here, plus this whole distance here, plus this whole distance here, plus this whole distance here. Alright. So we know that TS is 18. Now if PQST is a rectangle, it means that PQ is the same as ST. So it means then immediately we could say that PQ is also 18 centimeters. Alright? Now, they give us certain information. This is a rectangle. So if this is a rectangle, what it means, and TP is 9 centimeters, it means then that SQ is also 9 centimeters. Alright? So this is SQ. Now SQ of course wouldn't form part of the perimeter because SQ is on the inside of the shape. But why do we need this information? We need that information because having already been told that PQST is a rectangle, what that implies is that you have a right angle inside here because the internal angles of a rectangle would all be 90 degrees. Yes? The interior angles, sorry, the interior angles. You have to use your vocabulary properly. You have to say the proper thing. The interior angles of the rectangle would each be equal to 90 degrees. And if this is 90 degrees, we know that the angles at a point add up to 180. So if this is 90, then this also is 90 degrees. And if this is 90 degrees, it means therefore that the triangle QRS is, yes, you guessed it, a right angle triangle. Alright? And if we have 9 centimeters here, and we have the angle 30 here, that would allow us to find this side, and it will also allow us to find this side by using the trigonometric ratios. Right? Now of course, once you find the other one side, You could either use Pythagoras theorem or trigonometry, right? But we'll come to that just now. So if I have this here, if the reference angle is 30, it means that SQ here is the opposite side, because that is opposite to the 30. Good. I'll take out this little box here just for the emphasis that this is a right angle triangle. And we know that the sine of 30 is a half. But even if you didn't know that the sine of 30 was a half, because the truth of the matter is the angle wouldn't always be, in fact most times, the angle would be an angle whose sine you wouldn't know by heart. So you wouldn't always get 30 degrees in a question. I have seen quite a few past paper questions where you get 30, and me knowing that the sine 30 is a half, boom boom bam. Of course, if the student doesn't have that awareness, they can still work it out, which I will do now. But don't go into a question expecting that the angle is an angle whose sine you already know. Chances are that that wouldn't happen. So that is where our good friend the calculator enters the picture now. But look at the working. So we're trying to find SR using the sine ratio. So we could say that 9 over SR, right, opposite over hypotenuse, is equal to the sine of 30. The sine of 30 is a half. So we could say that, let us see, 9 over SR is equal to the sine of 30, which is 1 over 2. And I'll just write this out, right? If you don't understand the algebra here, there's a different discussion, but of course, we have a ton of algebra videos in the online platform too, right? Yeah. So 9 over SR is 1.5, and we cross multiply now. So you get 9 by 2 is equal to SR. So 18 is equal to SR. So therefore SR is equal to 18. So SR is equal to 18 centimeters. Happy coincidence that it is the same as this 18? That is not really important. The important thing is that they get what you're supposed to get here. So now that we have 9 here and 18 here, we could do one of two things. We could either use the, well, we could either use the tan of 30, we could either use 9 over QR as the tan of 30 to find QR. We could use QR over 18 as the cosine of 30, or we could just use Pythagoras theorem to find QR. For the sake of argument, I will do all three. But before I do that, let me just finish off. In fact, no. I will. Yeah, I feel out how to do it. Alright, so let me just run it quick. These are the decisions you have to make sometime, right? So having gotten that as 18, which I only had one option, which was to use the sine, because this is all I had. Now I have two sides. Let me go with the Pythagoras. With the Pythagoras, I could say that 18 squared is equal to 9 squared, opposites, right? Plus adjacent QR squared. So 18 squared is what? 324 is equal to 81 plus QR squared. 324 minus 81 is 324 minus 100 is 224. 224 plus 19 is 243. Yes, 243. 1 and 8, right? So 243 is equal to QR squared. So the square root of 243 is equal to QR, which is equal to what? The square root of 243 has a little less than 15, a little less than 16, and a little more than 15, right? 15 squared is 225, 16 squared is 256. See, I'm giving you a couple extra things there, right? So the square root of 243 is equal to 9 root 3, which is equal to 15.59, which would be 15.6 to 3 significant figures. 15.6. Now, hint, notice every time I have to use decimals, I'm using 3 significant figures. There's a reason for that. The reason is simply that the C6 syllabus, their guidance is that anytime you have decimals, where the number of decimal places or the number of significant figures is not expressly outlined. They didn't tell you how much to do it. They didn't say to 1 decimal place or to 2 decimal places or 1 significant figure or 2 significant figures. Anytime in a situation where you're not sure what to do and they didn't tell you, they are saying that you have to use 3 significant figures. So you will see me repeatedly using 3 significant figures. Of course, you have to know how to use significant figures, right? And yes, we have a whole video on that too in the online platform. Check it out. Yeah? So we're going again. 15.6 is QR. Let me use something else now. If we say that 9 over QR is equal to the tan of 30, right? So we could have used this and this to get the 2 sides, right? So we could have used 9 over QR to get that, and right, so maybe that would have been the better thing to do. That would have been the more sensible thing to do. But anyway, these are the little things that he does fine-tune in the course of doing plenty questions, right? This is not something I could tell you what to do or how to do it. You had to figure that out by doing questions. Figure out your own style in doing these things. Yeah. So if 9 over QR is tan 30, we know that the tan of 30 is 1 over root 3, which is 0.577. All right. So 9 over QR is equal to 0.577. So we cross multiply. So 9 is equal to 0.577 QR. So QR is equal to 9 over 0.577, which is equal to what? 9 over 0.6. Then this is supposed to be something like 15. Let me see. 9 divided by 0.577 is equal to, watch it, 15.6 centimeters. Same 15.6, alright? Right, so we found the length of QR using 2 methods. Having used the sine of 30 to find SR, we either use Pythagoras theorem, which we did here, to find the length of QR, or we use the tangent ratio to find the length of QR. Good? Yeah, that is how it is. There will be cases where you have 2 options to find whatever length you need to find. And of course, in an exam context, you're not going to use both options. You had to choose one. I am doing both options just for the sake of instruction. So how are we looking with the parameters so far? 18, 15.6, 18, 18. So we need to find this length here and this length here. Well, remember that PQST is a rectangle, which means that this triangle is also a right angle triangle. So we're going to put the little box in the middle here now, just to reinforce the point that we're dealing with a right angle triangle. And if this is 45 degrees, then what does that mean? It means then that this angle here is also 45 degrees. And by virtue of these 2 angles being 45 degrees, then we know that WPT is a right isosceles triangle. An isosceles triangle meaning you have the 2 base angles being equal, which means that the 2 sides opposite to the base angles would also be equal. And they have a right angle, so it's a right isosceles triangle. Alright, so 9. So if PT is 9 and PT is equal to TW, then it means therefore that TW is also 9 centimeters. Good? So we get the length there without really doing any calculations on the board. Of course, in an exam context, you had to write that out. That's the communication with the examiner. But we will deal with that in the paid platform as well. We can't do everything out here. Alright? Right. So now we need to find this length here, which we can easily do by using Pythagoras theorem. Right? That's the easiest thing to do because you have the 2 lengths opposite. Of course, you could use either the sine or the cosine of 45 to get this hypotenuse here. Alright? Same as 145 is the same as the other 45. So whether I use the sine or the cosine of 45, it wouldn't make a difference. because the sine of 45 is equal to the cosine of 45. Alright, so let me just finish off, let me just wind off here. Alright, so so we're going. So this is your 18 here, right? Right, so we need to use Pythagoras theorem over here. So we know that PW, which is the hypotenuse, squared is equal to 9 squared plus 9 squared. So PW squared is equal to 18 plus 18. So PW squared is equal to, sorry, 9 squared is 81, not 18. Alright? Common mistake. Right? We put 9 squared and we multiply 9 by 2. I will more than likely deal with that in a separate video, which may actually turn out to be a whole series of common mistakes that people make in mathematics. Common mistakes that could hurt you. So 9 squared is 81. 81 plus 81 is 162. Which means therefore that PW is equal to the square root of 162, which is equal to what? 162 square root 162 equal 12.727. Excuse 12.73. The three significant figures, 12.7. So that would be 12.7. Alright? 12.7. Now we could find the perimeter by simply adding up all these guys here. So we could say, therefore, after having done all the complicated calculations, we could now simply say that the perimeter of PRSW is equal to what? 18 plus 15.6 plus 18 plus 18, another 18 plus 9 plus 12.7. Alright, so let me see if we can add this without the calculator now. Alright, challenge yourself a little bit. Right, I have a particular student, I wouldn't call her name in this video, but she likes to do mental. Alright, and that is, I'm trying to encourage her to do it, because there are certain things you could do mentally once you get to a particular level. And of course, I also have to caution her now, because there are certain situations where she wants to go mental, but I had to tell her, no, take your time, use the calculator, no shame in the game. There are some situations where mental shouldn't even be an option, and there are some situations where if you're at a particular level, don't even bother to go mental. But as your level gets better and sharper and more acute, then yes, there are certain things you can do mentally. Alright, so I now have to encourage her now, just to encourage her to go along with it, cautioning her at the same time, but knowing that as she gets deeper and deeper into the maths, now she's doing that maths to her, she will get that level where she like, yeah, that is part of the process that I love when I'm dealing with students. Right, every student has their own different approach and their own different style, and you had to deal with them in a face-to-face context. Alright, now of course there's a limit to how far you could go with the individualization with respect to your students in an online setting, but there will be the face-to-face sessions as well available from September, but we will cross that bridge when we get to it. So let me finish with the question now. Alright, so 18 plus 15.6 plus 18 plus 18 plus 9 plus 12.7. so let me mentalize this one. 18 plus 18 plus 18. 18 by 3 is 54. Alright? 54 plus 9. So we add all the whole numbers together one time. So we still have a kind of system here. Good? Plus 15.6 plus 12.7. 54 plus 9 is 63. 15 and 12 is 27. 0.6 plus 0.7 is 1.3. 27 plus 1.3 is 28.3. Right? 63 plus 28.3, 63 and 28 is 91, 0.3. Again, don't get intimidated because I went through this kind of quick. Alright, if you have to go through it slowly, if you have to go through it with the calculator, just do that. Because at the end of the day, the examiner correcting your paper, wherever they're correcting it, wouldn't know the difference as long as they get the correct answer. So in an exam setting, you're not trying to race anybody, you're not trying to prove anything to anybody else, you're not competing with anybody else. The only person you're competing with is yourself. Alright, so no shame in the game if you have to use the calculator, no shame in the game if you have to use it, if you have to go slow. I just like to keep my own mind sharp by doing these things mentally whenever I have the chance. And if you have enough interest in the thing, you might want to take that approach as well. But that's up to you. So that is it. You would have heard me talk ad nauseum. Hey, all again vocabulary too, Latin and all, you know. You would have heard me talk ad nauseum about the online platform, so I'm not gonna really go into that too much now. All I will suggest is to go and check out the link. Check out the link. You'll see it at the bottom of the screen here. You'll see it on the post on Facebook. Check it out. Alright, and let me get the program going. So this has been our series on Pythagoras theorem and trigonometry. We're gonna do some other topics a little later, so stick around. You have plenty more coming your way.